Hello everyone. Welcome to this edition of the Software Developer Thursday. I'm really happy to see a lot of people here for this edition of the event. Today, Christian Gapp will present us what he did for the data browser 2.0. He will present us what's behind the data browser 2.0. And so I won't steal much time to Christian. Thank you for being here, and the microphone is yours.
Okay, Stefano, thank you. Welcome to the presentation of the Open Data Hub Data Browser 2.0. My name is Christian Gapp. So, sorry, first I have to start my timer, otherwise I will take too much time. Maybe that's not what we want. Okay, so let's start. Here on the right side you can see a QR code which links to the slides of the presentation. So if you're interested in, then you can make a photo. You can make a photo and go to that destination. So you have the presentation by your own. I show the QR code later on again, so you have enough time. Let's come to the overview. First, we take today a look at the Open Data Hub and its current data browser. Then we will take the next step. We will take a look at the data browser 2.0. We will see what's the vision behind it, what was the path to get to the MVP 1, the minimal viable product 1, which is the current incarnation of the data browser 2.0. We'll take a look at the requirements, at the challenges, and at the solutions that we implemented. And then at the end, we will have an overlook of the current status and an outlook of what is being done in the future. So let's start. First, we come to the Open Data Hub and its current data browser. So what is the Open Data Hub? There is an idea behind the Open Data Hub which is quite simple. The idea is to have a single access point to all open data from the region of South Tyrol. So I think this is a really nice idea. If you have data that you want to share with others, you can push it to the Open Data Hub or tell the people there that you want to push it. Maybe that's the first step. Then you can publish it there, and if you are a data consumer, then you will be able to get data from the Open Data Hub, either yours or that from other people. So there's a lot of interesting data inside, and if you have the time and are interested in, take a look at it. It's really interesting. Now, the Open Data Hub covers different domains. So it is more or less separated into domains. At the moment, there are the two big domains, tourism and mobility. And there are other smaller domains where it is not clear at the moment how to call them or how to unionize them under one term. So they are just called, it's just called the other domain. Now, the Open Data Hub has to work with lots of data. So there's a lot of data coming in and a lot of data that gets published out or that gets retrieved by the consumers. And therefore, it has to leverage a big data infrastructure. So it must work with lots of data. It must work performant. It should also provide the data in a scalable way. It should scale, it should scale on its own. In a way that if there is more traffic or more accesses, that it grows. And it's growing. Open Data Hub is in the process of embedding new endpoints, new data. So, and the Open Data Hub, you can access the data through different endpoints. For example, there exist REST endpoints, but there are also Sparkle endpoints. I think MQTT is something that is going to be released in the future. So there's quite something going on. This is the current architecture. And what you see in the image on the right side is not just the Open Data Hub, but also the parts beside it. So how to access it. And I think this is nice to get an overview of the architecture and the idea behind the Open Data Hub. So it consists of 5 parts. There are the data providers, which are maybe you or maybe other companies, or yeah. So here the data comes from, for example, there are e-charging stations, there's parking data, but it could also be some hotel data or some point of interest or where the data comes from. Now, as part of the Open Data Hub, really as the server, there is the data collectors that are here to read the data. So you can push the data to the data collectors, or the data collectors are implemented in a way that they can pull the data from your sources. Now in the Open Data Hub core, there's a writing part and some storage, some modification, maybe some aggregation, and a reader part where other endpoints can read data from and publish it from there. So usually those are the REST endpoints, for example, for accommodation or for e-charging, for parking, for weather, for the data that's inside the Open Data Hub. Those endpoints are not just only REST endpoints, they are again Sparkle, maybe MQTT in the future, and so on. And on the right side, you see the data consumers. That might be an app or a website. The data browser, for example, is also a data consumer. So yeah, this is the whole picture of the architecture of the Open Data Hub. Now let's take a look at the current data browser. So in my opinion, it is nice to have something to view at. Therefore, I show you some screenshots, and maybe you get an idea what I'm talking about. Yeah, we see on the left side the table view, as we call it. So it's an overview of the datasets. And on the right side, we see a detail of such a dataset. So in principle, it's just a web application that allows one to interact with the data from the tourism domain. And yeah, one can navigate the data. One can even edit the data if you have the right authentication and authorization. And yeah, it provides a list view or table view, as we see it here. It provides a detail view and edit mode if one needs, or if one has the right to edit the data. So this is the current data browser. It works quite well. Now the question is, why data browser 2.0? So we have something working. Why put it away and make something new? There are some shortcomings of the current data browser. One is that it supports the data from the tourism domain only. So this is a problem, but it may be solved by just implementing support for the mobility domain. Nobody says that this is not possible. It's possible. But the real problem is that the technology that is used by the current data browser, is a bit outdated. It's a .NET AngularJS application, and I think many of you know that AngularJS is already a bit old, and it's not so easy to find people that want or that can work with AngularJS. So this is kind of a big obstacle. The next shortcoming is that there are only limited development resources, even at the team that is providing the data browser at the moment. So as far as I know, there is one person that is in charge of keeping it alive. And yeah, if that person yeah, who knows, or wants to go to somewhere else, who knows. So this is really a problem for a project if you don't have the people that can maintain it. And yeah, therefore there was the question, should we improve the current data browser or should we do a rewrite on a plain field? And looking at the shortcomings, and yeah, the decision was to do a rewrite. So this takes me to the next step, the Data Browser 2.0. Now, what was the vision and the idea behind Data Browser 2.0? So there was some learning that we got from the current data browser, and from that on, one can improve. Now, a clear vision was to provide easy access to the open data hub data, so that everyone that knows how to work with a computer, and that's, I think, today 80–90% of the people worldwide, can or may access the data and can take a look at it. The next vision and important part was that the user interface and the user experience should be nice, so that people want to use this product, not just that they see it the first time and throw it away because it doesn't work or it behaves in some strange ways. Now, the next idea or also vision was to unify the views over different data sets. Now, as I said before, there are different domains, and each domain has a lot of data sets. At the current state, is that the data sets or the types for the data sets are a bit different. So there may be some GPS data that's defined in one data set like this, in the second data set a bit like this, and in the third data set it's completely different. And that's some technical detail that's not interesting for the user. The user wants to have a unified view. So that's one goal where we want to arrive to improve on that. The next important part was that the new data browser should allow to access new data sets without code changes, so without changing it. The thing is, the Open Data Hub is growing, so they are getting added new data sets and even endpoints in the future, I think. And the data browser should present new data sets without being modified, so that simplifies that new data can be accessed by users. Otherwise, it can be that it could be that a new data set is released and nobody touches the data browser, and for half a year or a year, nobody recognizes that there's a new data set. And at the end, not the last and not the least important, but another vision was that during the project there should be room for exploration of ideas, so that there is some goal, but there is time to find a good solution to get to that goal, not just to jump to the first solution, which is also a way to go forward, but here to take some time and to really try out stuff and to see what works and doesn't work. And I think this is a really nice thing to have in a project if this room is available. Now, so how do we plan to get to the Data Browser 2.0? First, the team has to be built. So the current iteration of the data browser is an effort of different teams. There were designers, there were implementers, there were project managers, and so on. So already quite some people working on it. And then we come to the project management part. So there were some gathering of ideas and requirements. Then the features had to be prioritized. And then the strategy was to implement the Data Browser 2.0 as a series of product increments, where the MVP 1 is the first of these releases. Let's call it releases. And there will be then the MVP 2, 3, and so on, until we come to a release where we can say, okay, this is now official, and this is the new data browser, you can use it. At the moment, the MVP 1 is it's working. You can access it under this URL. you can take a look at it, but be warned, it's not perfect. There are some bugs and some stuff that is still in the process of being implemented. Okay, so what were the requirements for the MVP1? First and simple, it should be a web application. It should run on the web, it should not run on the desktop or be an app or something like that, it should be a web application. Then it should support authentication and authorization, because there is, it should be possible for some people to edit the data, and therefore we need authorization, authentication. Then it should provide list, detail, and raw view. As we have seen before, the current data browser already had a list view, which was the left image, and the detail view, which was the right image. And we don't want to lose functionality, so this should be part also for the MVP1. Yeah, I'll talk a little bit more about it later on. Then another requirement was that a user should be able to filter the data so that it can narrow down the focus and get to the data that's interesting. Then it should provide data export, so one can download the data. And then it should also provide some tools for developers. So developers are one of the people that you want to have as audience and as users. And there's some simple stuff that you can do to make the life of a developer easier. For example, you can provide URLs that are used to fetch the data, or you can provide the responses in a way that a developer can work with it. For example, you can show the JSON of the response. So that's something where a developer can take a look at and get the first impression of what is going on. So yeah, this is the current design. As I said before, it's nice to have something to view at, because otherwise who knows what this guy in front is speaking about. Here is the start page. It's just some, let's say, landing page where you get an overview and some description. Then we have here on the upper right side the list view. Yeah, you see also a description of the current data set we are looking at. There is language switcher, pagination. That's all stuff that's also in the current data browser. Then there is the table. Here we have some links for the detail and for the raw view. Here are the other links to get to the detail view and raw view of, for example, this data set. And then the filtering, you may see it. There is this arrow, so the filtering now happens through the columns of the table. In the current data browser, there is some dedicated space where the filters are shown. Then we have the detail view. Again, the header with the general information. And on the left side, you see the categories. And here you see the subcategories with the data. And then we have something for the developers. We have the raw view, where you can see the JSON response that came from the last data fetching of the API. So this is something nice, and we use it also while developing the data browser. Now, let's come to the challenges that we met. Now, one thing is that there are a lot of data sets in the domains and a lot of different data types. Now, how do you render that data? First, we had the idea that we do an explicit implementation of all the views for each data set. That means you have, for example, a data set for accommodations, then you implement accommodations. You have a data set for point of interests, then you implement the views for point of interest. So this is possible, but it's a lot of effort and repetitive work. And it is difficult to get some more advanced stuff that we want to have. For example, it's difficult this way to have dynamic changes of the views. Maybe a user wants to change the column ordering in the table view, and that's something that we want to allow to the user in one of the next iterations. And another thing that's difficult is to display data sets where no explicit implementation exists. So if you don't have the implementation for the view, you won't see the dataset. In this case, where you do really the explicit implementation of the dataset. So therefore, we choose the solution to render the interface based on a configuration. And I think the idea is quite simple. You see it later on a little bit more how it works. But the idea is just you render the UI from the configuration. If the configuration changes, the UI changes. So you can change the configuration dynamically. For example, the user clicks something or sorts something or does stuff, whatever it wants to do, and we allow it to do. And the configuration is adjusted, and from there on, the view changes. And another nice thing that is possible with such a configuration-based stuff is that the configuration can be created on the fly. So if we get new data where we don't know how to visualize it in beforehand, we can inspect it and build out of this data or of this information a configuration that we can use to show that data set. So this gives us the ability to access or to present new data sets that without code changes. Now, how does such a configurable view rendering work? There are three ingredients. First, you need the data. Then you need a configuration that says, okay, I want to take this piece of data and want to show it like that. And if you combine that and you have some dynamic rendering of the components. So if you use the configuration and say, okay, I want to render it, for example, with an image, here it's cut off, but with an image component, for example, then you get to this one. So data, configuration, visualization, and yeah, this can be either hard-coded or built on the fly or modified by the user, so it's quite flexible. So this was one of the challenge and the solution for it. Another challenge was how do we integrate data filters? And the question is, if the UI changes, how do we map this to API queries, to the queries? So, example, a user wants to activate a filter. Now there must be some data fetching from the endpoint with the information that this filter is activated. Now, how do you come from the event to the action that data is fetched? And yeah, we choose a, I think, straightforward idea, which I think is also known, where we use some state management, and then based on state changes, on events, and then later on state changes, we can do some actions. So for example, we have the UI here, and the user triggers an event, for example, clicks on a data filter, activates data filter. So this event changes the query state, and this is the state that we keep internal in the application. And state changes can be observed and be acted on. So now, if the state changes, for example, we fetch the data, and on the other side, the UI may observe changes of the data and display the new data. So this is also gives us some reactive behavior, which is nice to have. Now a little bit more details why this query state and what we can do in addition with the query state. So to have this query state gives us some nice properties. First, the state can be changed by events, so anything that is able to publish events or to, yeah, let's say publish, emit events, can change the state, and those changes can be observed, as we've seen before. For example, user clicks on the filter changes the state change is observed, and triggers a fetch of the data. So another nice property is that the state can be inspected. So you can take a look at the current state and you can see, okay, this filter is set, this one is not set, and so on. And another nice property is that the state is descriptive. So it's, in our case, it's just in-memory representation of a data structure, but you can serialize it, for example, to a JSON or to whatever you want. And the state can also be synchronized. So you can take this JSON representation, for example, mail it to anybody else, and that one takes the JSON, puts it inside his data browser, and has the same query state. I think that's something nice to have. Yeah, and those properties allow us to do some nice things. For example, as we have seen before, fetch the data on query state change. So the UI changes, in the end, the data will be fetched and visualized in a reactive way. And another nice thing that we can do now is that we can, for example, synchronize the query state with the application URL. That means if you change, for example, the filters, this will change your URL, the application URL. So, and if you change the application URL, this will change the query state, and then from there on trigger, for example, the data fetching, which will then be visualized. In the end, this allows us to have URLs that you can share, and where you have the information about the query inside the URL. So I can send you a URL and say, please take a look at this dataset or at this filtering and tell me if it's correct or not. And yeah, one can do that with the URL. So you can try it yourself. You see here is the almost same URL as before, but just with some additional stuff. And here, for example, you see the properties that come from the query state. Now, if you open this URL, you get exactly to this data set and to the filter settings that are defined here. If you change active to false or language to something else, it will react appropriately. So now let's come to the overview of the solutions. Implement web application, use some framework. In our case, we used Vue 3 and Tailwind CSS for styling. Support authentication authorization. We use the Open Data Hub Keycloak. Provide the configurable list, detail, and raw view. This is the stuff, this was our first challenge. We said, okay, we want to implement a configurable dynamic rendering of the UI. Then provide the data filters. This is the stuff with the query state that I was talking about. Provide the data export. This is just take the fetched data and make it downloadable. This is some HTML and JavaScript stuff, mostly Stack Overflow, I think. And this provide tools for developers, so we have the raw view, and we also show, for example, the URL from the last API fetch, so you can copy it, insert it, for example, in your browser or do some curl or something, and you get the data as it is presented. Okay, so we are reaching the end. Current status and outlook. Now this is the current status of the data browser 2.0. We are at the moment, we have released MVP 1. And you see, this is the stuff that was done. So this is mostly the stuff that we saw before in the requirements and in the solutions. Then we have some proof of concept for this automatic configuration, or to support new data sets without code changes. We have some proof of concept for web components. So most probably there will also be some integration of web components, especially for detail stuff. So this is something that is reusable, and it will be also released on the web component page of NOI. So you can take a look there and use it on your pages or in your applications, wherever you want. And here you see other requirements that were not started yet. So this is a lot of work and a lot of goals to reach for the future. A lot of interesting stuff to do. And yeah, if you're interested to work with us, just tell, I think, Stefano, or he'll let you know afterwards how you can reach out. Yeah, Outlook, the next milestones are planned. So we have, I think, a rather good idea on what is happening next. There are some challenges that are upcoming in the next iterations, one being the support for the new datasets without code change. So this will be quite a big challenge. Then the edit mode will be a challenge. First, it may seem simple, just show the fields and change them and save it, but there's some tricky stuff going on there. Then user settings, so a user should be able to adjust the view to its needs. And yeah, those are the challenges, more or less, the big ones that should be completed by the end of 2022. That's the date when we want to release the new data browser. So that's it. That was it. Thank you for your attention. And if you have questions, just let me know.
Thank you all for the attention. Now it's the question and feedback time. If you want to help us, contribute us, become a Open Data Hub community member, just write at info@opendatahub.bz.it or help at opendatahub.bz.it, and we will be glad to have you on board. But now, please post your questions and observations.
I have one.
Okay.
Hi. Thank you for the presentation.
Yeah, welcome.
Could you please go one slide back?
Yes.
I just have a little feedback.
I think one to this one.
Yeah. It's about supporting your datasets without code changes.
Mm-hmm.
And I think you had a pretty good idea with the configuration thing attached to the dataset. What if data providers give you the dataset together with the configuration that's needed to read their own dataset? Because the data provider is the one that knows how to read his own data.
You're right. Yes, that would be an idea. Sorry.
For the online streaming.
Yes. You're right. That would be an idea, and it's maybe also an idea that has to be discussed or should be discussed. In this case, the configuration is just for the data browser 2.0. It's just a UI configuration. So it's if the data provider is interested to provide a UI configuration for data browser 2.0, then yeah, that makes us the life even easier. But it's something very specific for data browser 2.0. And I'm not sure if data providers will do that. If they do, perfect. If they don't do, yeah, we have to find some other way. But yeah, the idea is good. So if somebody provides the data, this one most probably also knows how to show it or what is important. Yeah. So.
I also have a question.
Okay.
This one is more about the data hub itself. If I develop something that it's based that relies on the data hub, do I have any availability and assurances of the service? You mentioned already that you are aware that it's a big data system and it should scale.
Should.
Does it do that? Is it, how reliable is it up to now? And yeah, do you have any feedback on this regard?
That's a question that I have to forward to the people that know it better than me.
Okay. I can answer this. So the Open Data Hub, which is the data browser, is a kind of data consumer and data provider for the Open Data Hub. No? And the Open Data Hub itself is used by many projects. I see Chisma here, who is using it for the data on the highway, on the A22 highway. where there is data coming in every second about which cars are traveling, how much pollution they are generating, and so forth. And the algorithm by Cisma and the University of Trento is calculating a prediction about if the emission exceeds certain limits in half an hour, considering the environment like meteo and other data, and pushes these results back to the Open Data Hub, which then provides it to the A22 operators who can implement a dynamic speed limit on the highway. And this is in use, so this is really huge data coming in very quickly, and it works. And therefore, we are kind of confident that the system is ready. What we are now implementing is also contracts for certain data consumers. So data consumers being it, most of the data is open data, so you don't have even to register to get the data. If you want to get data which is not released as open data, you have to register. And when you register, you have also the option to make a service level agreement with us, where we guarantee certain performance. But these agreements, we can't. This offering, we can't offer it for free. So these premium users will then make a contract with us and have service level agreements. So this is the structure.
Thank you.
Welcome.
Thank you very much for the presentation. My question is about the data type that you are collecting now, that you want to collect in the future. Because, for example, as direct research, we manage a lot of special data sets that are time series but not in real time. So I don't know if you are interested in this type of data set, so time series or vector data, raster data, because maybe useful for you to think right now to the data visualization. So now that you are developing the new architecture, it may be useful to think to different data types. So my question is related to the data type that you want to collect.
Yeah, in my opinion, it would be nice to collect any kind of data, because data is really nice, and to have it open source means that anybody can use it and create new stuff out of it, or just to learn or to improve, to match, and so on, so to work with the data. It's interesting that you have this kind of data, so I'm not sure, but I think some of this is not yet part of the Open Data Hub.
No.
And yeah, it's good to know. And I'm speaking now for myself, because here are the guys that really are in charge of the Open Data Hub, and I think it's best I forward this part of the question also to them.
I answer? Yeah. Okay. So at the does it work? Yeah.
Yeah.
No. At the moment, we have two types of data. At least we think it like this. We have time series, so measurement data from sensors. And on the other hand, we have content, which is mostly from the tourism part, where you have descriptions of locations, point of interests, accommodations. There is also some data like pricing, which is changing, but we distinguish between mainly descriptive data and time series data. What we don't have is raster data. I know you have at OIREC. And we don't know if we are able to open up for this. So what we are looking for is more to collaborate with you. You have a huge data storage and specialized systems for handling raster data and this kind of maps or satellite data. And what we are discussing internally is if we should just through the Open Data Hub, which is a kind of hub which connects data providers of different sorts. In this case of data, just link to your system. And because in other situations, often for performance reasons, we are not only just forwarding the call to the data provider, but we are also storing the data in our open data hub. We are kind of a cache of the whole data, no? But I fear that in your case, the data gets so huge that, and the increase in performance, I don't think there is any. So it's probably not wise to integrate the data directly in the cache, let's call it. And what we don't know yet is if for this kind of data, we should create an editor, kind of web component to edit and visualize raster data, or if we just should delegate to more professional or more dedicated vertical editors. This is still open, but could be an interesting idea to have web components integrated in the data browser, which then visualizes the data directly from the data provider, which could be RLM, for example. Could be an idea, but it's still an open question for us. There was a question about Claude.
Okay, thank you. So building on top of his question, more focus now on the data browser itself. Did you guys already figure out what kinds of data browsers you need? Because, I mean, what I have seen when I access the URL you have now, you have table-like data. I can imagine that for the kind of data that you're handling at the moment, you also might be interested on like geolocated data, so displaying information on top of a map. For time series data, let's say, for the case of mobility information, maybe you want to show some graphs for the time series. Have you already decided or chosen a scope for what kinds of data browsers, because these are actually different data browsers, that you want to build with that strategy that you are doing? Because I'm interested on the different kinds of data browsers that one would like to have.
So what we, good question. What we want to achieve is to integrate all of this representation into the data browser. For example, if we have GPS coordinates, we can show that in a map. And we could show the map inside the table, but for space reasons, I'm not sure if that's a good idea, but it's possible. So the architecture provides us ways to display the data any way we want. This will be done, I think, or where it is more feasible to integrate, for example, maps and diagrams and stuff like that, is in the detail. So this is really the detail for one exact data entry. Yes. And here we have the right, I think, in my opinion, the right place to show maps, to show diagrams and stuff like that. And it's possible with the current architecture. We can do that. So here we have the table view. This should just give an overview of the data inside a data set, to have some filtering, to see, okay, if I don't want to have the, I don't know, provider from, something like, or if I want just the all entries that have a German description, then you can do that on the overview page. You can select, okay, now I'm interested in the details of this data set. You click here on the detail button. Sorry for these two buttons on the table view, they should not be there, but as I said, MVP 1, so there are some bugs. Yes, and then you come to the detail view, and there you have other kind of representation too. But in principle, you can also put a map here. Yes.
I would just add that I would be interested to see other kinds of visualizations beyond the table, like for collections of data. Because if you think of, let's say, for the transportation system of South Tyrol, you can see the map, and on the map you can see all the points for the bus stops. So that's like if you have accommodations, if you have events, all those things that's a different kind of data browser, but still it's nice to show a collection of data. It's not a column. It's like you take away the whole column thing and you place on the map. So this is the second kind. A third kind would be the graphics for the time series. So for collections as well. So if you learn what are the different kinds of browsers that are more useful to people, let me know. I'm curious.
Yeah.
We show you another visualization. So it's a dedicated tool at the moment. Maybe Christian doesn't know yet, but it has to be. Sorry. Maybe Christian doesn't know yet. It's another challenge we have for him for the data browser. If you go on analytics.opendata.it, you can activate and see at least the Open Data Park, because otherwise you would have to log in. You see all the measurement stations providing data to the Open Data. This is more this time series data kind of data and view. And at the moment, MVP 1 of the data browser is more the content data type approach now. And the challenge will be to mix the two kind of data in one single data browser. We don't know yet how we will do that. If instead of a table, you will have a map, and then you can activate data. And when you click then on these links, you will get the graph, in the time series. No? So, but I don't know if did you know about this challenge?
Mobility. This special challenge, not, but I had an idea that something like that will come along. Yeah. So yeah, good question. Yeah.
This is data browser 1?
No, this is.
No, this is another tool. This is really the analytics.
It's another tool for you.
Yeah,
Okay.
for the moment we have two tools, and they will merge into one data browser.
Yeah. One of the goals of the project is to make from two tools as one. We had the need to start from the tourist one, so the 2022 will be fully focused on the tourist one in order to reach the goal to switch off the old tourist data browser at the end of this year, we hope. But in the second half of the year, we will also work at least to understand with our expert in UI, UX that will help us in developing how we can merge the two tools in order to not lose usability. So that's a long-term view, and next year, Christian, now you know what you have to do.
Thank you. Just let me add, because a bit in this project as well. So the thing you're speaking of is grouping of data, because we started from an overview, from a table overview from single records, and to the detailed view of those records, and to show those records and classify them, categorize them, and so on, and see the raw data and so on. But if it comes to sensors, like we see here in analytics, you may be interested in comparing them and see them on a map, but that's grouping of data and see them together, comparing them, and so on. So the thing we see right now on the screen. So that's one thing we didn't think yet into this data browser right now, but that's, of course, once all of this is done, this is the next step to do, because that's, of course, this time series data where you have different data and one single data record doesn't make sense because you get no information out of it because it's one number, one value. If you understand the real value after you see the others and compare it and see which ranges are there, minimum, maximum, and so on, or you see where they are. So I think that's the important, really good input, and that's the next step after, I don't know, MVP 4.
No. Cool.
I would like to ask the idea, could these charts be made available over the web components and make them usable also for application development?
So if I understand right, you mean, for example, to make this whole stuff one web component that could be reused. Okay. So yeah, we were talking about how much of this whole application can be done as web component. So once there was the idea that the whole application is composed of only web components and that we don't use other frameworks. But that, Patrick had the idea. But then we had some collision with reality, and we saw that that's not the perfect idea, because if your web components are very basic components, so the intention, I think, was to have something like an input field or get more fancy, a map or something like that. But if you want to build up an application from web components, you need to manage state, to manage URL stuff, and so on. So that won't be a problem if you say, okay, I just want this stuff, there are the rest that is not interesting for me. But here you have then to provide somehow the data in some form. So for web components, you have to provide it as property, not as attribute, because, and yeah, so there was the idea to use web components. At the moment, we use just view components because that's our framework and it makes our life a whole lot easier. But nobody, or it's not said that in the future this could not be a web component. Yeah, in theory that's possible, yes. But it's not done now.
But it would be cool, no? Listen.
Yeah, it's the thing with web components is, as I said, so they are very, very low level, so they are really near to the DOM and to the JavaScript environment, and they don't provide more elaborated stuff that you get from a framework. For example, also the slotting mechanism in web components works different than for all other frameworks, because that's the way it was designed in the HTML and the DOM, so 20 years ago, and they had to stick with it. And there are some decisions they made this time ago, and not all of those decisions are state of the art, and they are a bit problematic sometimes. And rather than to do all in web components and to work around this whole stuff and to re-implement everything that the framework provides, we choose. But for example, here or also here, we want to implement the web component. Parts of this stuff can be web components that are reusable. And maybe, who knows, in the next step, this whole stuff will be a web component, yeah.
MVP 3.
2.5. To keep it a little bit.
Challenging. Now it's your decision which to take.
Well, I want to express my concern, but it's also a question because I tried the application and I had some troubles with the searching process because there's nothing implemented with the search. Like there's no searching tool already implemented. So you have these two categories in the mock application, and you have these drop-down menus in which you have the categories, the different data sets. I think that,
yes.
Yeah, I mean, you have the different data sets. The view is the one you were displaying there, like
accommodation and point of view.
one under the other. But I would like to know if that's just an example for the mock application, or you want to implement everything with these like drop downs, or you want to insert like a tag-based search tool to access to the different data sets. Because I mean, it would be a solution also to address the problem of the different the tax solution would address also the problem of the style of the data along with the content.
So let's see if I can answer your question. What you see now is the MVP one. So we choose to keep it rather simple for the number of data sets that we have, because we said we invest the time in other stuff. Providing other data sets is like, how you say, it's Fleißaufgabe, don't know. It's something that's not that difficult anymore. So we focused on 2 data sets to show them. There are a lot of others. It just has to be configured in our case. Now for the searching stuff, there is the plan to have some search, but at the moment the search would be only for a given data set. So you can search inside the data set, for example, for the name of an accommodation, something like that. If I understand you right, you would propose also to have some search across data sets. Is that what you meant?
Instead of having like fixed categories and accessing all the data from a specific category, then
Yes.
just be able to like search across the different like sets according to some tags, some keywords that you were interested in.
Yeah. We don't have that at the moment.
But is it in plan?
What is in, so we have the plan that we make the data sets searchable. And for that, I think there is the Elasticsearch is used I'm not sure what the technology behind, but most probably it will be Elasticsearch or maybe a PostgreSQL. Yeah, doesn't matter. It doesn't exist yet, and I'm even not sure if there is an easy possibility at the moment to do something like that. But it would be really nice to have something like that. Because then as a user, I can say, okay, I want to search everything that is located there. Give me everything, for example. And that would be nice to have. But at the moment, this kind of stuff is not in the planning. Maybe that's then data browser, MDT. No.
If I can add here, one thing we have started to develop in parallel is a Sparkle endpoint. Does it work? Yes, here. Pam. And on this landing page, sparkle.opendatahub, etc., you can send Sparkle queries to the Open Data Hub. And in the knowledge graph, it's modeled multiple data sources as a single knowledge graph. So you can do cross data source, cross data provider queries. So you can query how many cars are near to huts on the mountain, where huts on the mountain comes from one data provider which provides data about tourism, but the cars comes from another data provider who manages mobility. So this is the idea of a knowledge graph. That could be something used in your use case. There is a request on the table to have something like you described, a generic search in the data browser to find data. That would be very valuable for people doing data editing and having to fix some data and to search problems or errors in the whole data set. But we are still figuring out if, for example, Elastic could be the solution to do that or not, if it is easy or not. For now, we are concentrating on the single data sets and make them searchable. Let's see in the future what we can add. If you have suggestions, we are happy to hear them. That's even something I would like to share with you. If you have any suggestions or you want to contribute in some way to the development, just drop us an email on help@opendatahub, etc. and we come back to you, and we will see if we can start a project together with you. Okay?
Okay, another question for Patrick, is able to answer it. About the architecture of the Open Data Hub, what are the resilience strategies for it? I mean, are you able to tell us a bit how it is hosted and with which uptime guarantees? So I would be very interested in.
You mean the infrastructure?
Yeah, where it runs.
At the moment, Open Data Hub is composed of two development branches who have been merged together in 2016. One branch is based on .NET, was based on .NET development, C#, .NET, which has been migrated to .NET Core. And so we could unify the infrastructure using only Linux servers now. The other branch is on Java technologies. And what we are, and from the startup from 2011 running on Linux. And we unified the backend databases on Postgres. We are using, there is some exceptions, but let's say we are using only Postgres. There are some legacy exceptions which are still in migration. But we are consolidating on Postgres as backend for a rational database, rational database data, as well as for NoSQL data. We manage NoSQL data in Postgres. Postgres has the ability to do that, and the performance is quite good. And we are now migrating in direction of bringing everything in a microservice architecture and Dockerization and so on, but we are still working on it. You know, these things which take longer than expected because you have other priorities always. Huh? And we are completely on AWS as a cloud provider and have a backup on Google Cloud. So we have two cloud providers, so should AWS fall out completely, which I don't think, but some of our consultants are very, let's say, they want to mitigate every risk. So we have also a backup solution on another cloud provider, which is Google Cloud. Does this, yeah?
For time series data? Like where do we store the time series data?
In Postgres.
Also Postgres.
Yes. We don't have a dedicated, how is it called, the database? InfluxDB. Yeah. And we have some Elastic, I don't know if that counts, I don't know exactly for meta
logs.
Search. Huh?
For the logs.
For the logs, okay, for the logs we use Elastic, exactly, yeah.
Hello, I wanted to know if you have any plans to add features which improve collaboration between people who use your data sets, provide different views on it, like apply some algorithms, publish a paper or something like that. So they could share it, get some feedback and other such things.
So you are, just to understand your question, you are thinking about systems like Jupyter and this kind of, so for papers, so?
More like you may want to use the data to publish a service which others can inspect, they can give feedback, what could be improved and such things.
Okay, I think I asked Roberto to answer this question. Huh? We don't have it in the Open Data Hub, but I think Eurac has something in their system which is going in this direction.
I'm not sure to have understood what correctly as you, the question. You are meaning that if there is a system that can allow you to create, for example, a ticket that can be a message to or a suggestion for improvement, isn't it?
No, I think he means about if you do a publication about
How to
data.
use the data.
Huh?
You make a publication about data, and then also you put.
You want to have comments about the publication and refer the data. Exactly.
Yeah, like you can share your products and then other people can see them, give feedback on them, and maybe use them for other services as well, like integrate this data into other services as well.
So like a collaboration platform for data.
Yeah, exactly.
Yeah, but in this case there are many solutions, but I think that this open data hub is already intended to be in that.
But
in that
how
way.
do you comment on that? Because element check. No. All right. So I give you just one. I don't know if you are on the element channel here with this computer.
No,
But on the Open Data Hub website, you find one information but can you explain afterwards? Okay, okay, I have to take the, okay, sorry. On the Open Data Hub website, you find this community link, we call it community, and there you see the data providers who is providing data and the data consumers. So data consumers listed here are those data consumers which officially did an agreement with us. We don't know all the data consumers. It's open data, so everybody can connect. But those who do an agreement with us are official data consumers. So you see this, and then you see the data sets. So you can find data sets to use in your project. And the last extension, official at the moment, is the web components. So we have a list of web components which are published, which are built on top of data. I wanted to see something I was looking, but it's okay. Like the mobility, exactly, this one. So here you see the web component, which visualizes the e-charging stations. So we are here, and outside of NOI, there is a charging station. It should, this is the demo effect, it should load information about the charging station outside. At the moment, it's not working. And what you see is here the link to the license and to the Git repository. And here you find the source code about how this web component has been created, so you can fork it. And if you have a web component which uses data, you can also publish your web component on our web component store. And so you find others who maybe use your source code or collaborate with you. This is what we have at the moment. I don't know if you have an idea on how to create a platform to share more projects using the data. We would be really interested in implementing it. You have a?
Not really. I just have a general idea, like some forum where someone can post a rep and other people can give feedback or things like that.
Okay, that's what Peter mentioned. But here on this computer, I think it's not running. We have an element channel. You know element from Matrix, distributed, blah, blah, blah. Yeah. We have an element channel. Here. Open Data Hub. Yeah, maybe it works. Yes, it works. Yeah, and you see I'm posting pictures of projects implemented with the Open Data Hub, like this e-paper screens, which two companies at NOI have created and which connect to the Open Data Hub to visualize the last events of the senior rooms here in the NOI Techpark. So this is kind of a channel we use just to share information. It's quite young, but if you are interested in joining us, usually the easiest way to get in touch with us is to help at Open Data Hub, etc. Okay, thank you. And then I would ask Roberto to give some information about how researchers are integrating with, it's called Jupyter, this tool, and you provide this.
Yeah.
Yeah, can you give some info?
I can give a short introduction, but let's say the Jupyter Hub is a tool for doing, is a sandbox at the environment that allows to analyze the data, to process the data. And we integrate it in the environmental data platform, a similar tool like this that enables researcher or other, let's say, registered user to work with the data, not only to visualize, but to make interrogation, to do analytics on this data. But I guess the Jupyter Hub is a well-known here in the audience tool.
And you provide this for everyone? How does this work? So everyone can go on your platform and make a Jupyter entry and refer to data?
Let's say, let me do also a comment to your statement of before in how we can really eventually from different data types, since we are managing a lot of raster or graded data. Your suggestion to say have a connected and linked, let's say, access to that platform is in principle a very straightforward working solution. In the vision that we have and we are sharing also with researchers, the idea in also in browsing data and visualizing data will be really interesting to have a simultaneous visualization of different data types in the same web application. And this is really something that I would like to work together with you, but I'm sure that also we have a nice project probably in a few months where we can start really concretely to work on that. On the other side, answering your last question, we have a similar or the very same technology, key clock, that enables authentication and authorization. The authentication is then requested to our, let's say, scientific net that is already in place in all the South Europe, that is managed by the ICT of Europe University. So, and the authorization is provided through key clock component. So, in that way, everyone that has been registered in advance can access, according with the authorization that can be assigned, can access different type of data.
Okay.
And can access also the data not only in visualization, but also accessing, gaining really grant to even to download the data, or accessing, let's say, this environment for analytics, that is this Jupyter Hub. In the environmental data platform, we also set it up a discovery service that is implemented with standard metadata that are well, let's say, description about the data. And we added also, beside the description, explaining the origin, how the data is being produced and whatever. We also, whenever it is possible, we added different pieces of snippet code that enables also users to just copy and paste that code and integrate in their own application or in their own working environment. So this could be also something that can be easily integrated in the Open Data Hub, I guess.
Yeah, great. There's a question? Oh, no?
Yeah, I do.
Yeah. Thank you.
This is about the data browser itself. So you showed before a feature of the data browser that I can like select some queries about my data and then share the query with someone, and then he gets at least the same results. But as I saw it, as soon as it is using still name addressing the URL, for example, it had a query parameter page number 2. And let's say I'm looking at a data set of labeled data of pictures that have been taken in South Tyrol about plants, and this is, I don't know, the type of the plant with the connected image, and I want to use that dataset for doing some machine learning stuff. My concern is this: if I do this query, I get a pretty good dataset that it's pretty fine for me. I export it, so super cool. And then I take the query because I want to later replicate the job without having to keep the data myself, because we have the hub, I would like to keep it there. I have a visualization tool for the hub, so all good. In 3 months, I do the query again, and I suspect that if someone adds like 1,000 images to that dataset, I will get a different result. So my research I would not be able to replicate my job. My question is, could you please add also a content-based addressing URL scheme, which is something like in the URL you have a hash of the content that I saw. So if I do the same query again in 3 months, I get the very same dataset that I saw at that time. Is it something like considered? And are my suspects correct?
So yes, you're completely right. So the data may change, and if you invoke the same endpoint 2 times and the data changes in between, then yeah, you get different data. So what you want, in your case, what you need, I think, are snapshots. So you say, okay, this is the stuff that I want to get.
Yeah, and I think it would be very good to super cool feature that could be integrated in the data browser itself, because I can explore the table, so I see the data set that I'm going to get, and then okay, snapshot that, persist this query, I want this again and again.
But you have to snapshot not only the query, but the data.
Yeah, somehow the URL should contain a link to the snapshot. That's true.
Data has the solution already.
You already implemented it.
I have the solution, but it's not implemented yet. So we are a microservice, so the Open Data Hub is a microservice architecture, so things are working differently for different domains. So on the mobility data sets, we have this snapshotting for the measurements itself, but we don't have the snapshotting for the metadata. So, for instance, if you get a data set from A22 and A22 is called A23 now, then it's called A23. So but the measurements are snapshot, so you will always get the same data set if you provide an interval in the time range. We are working, it's on the to-do, to have everything snapshot on the mobility domain, also the metadata. And at the moment that's not. So yeah, that's even maybe on the tourism domain, I think only some searching and filtering is snapshot, but not everything. And that's also, yeah. Because at the moment our need was to have an API to provide data for visualization for people that look at the moment. So they want to know what's going on now and not for the history. And the only need for history was the time series tables, and these time series tables are snapshot. So there are only inserts in the database, no updates, so to make it clear.
Okay.
Good question.
Let me just add a cool question or more questions.
Good question.
Good question. I just wanted to stress the point Peter made also. The idea to send to someone the link is mainly come from the support team. So we have often the problem that somebody has to help someone else in editing the data. And so it's very easy then, if you have a view, you create your filters, and then you copy the URL, you send him a chat message and say, look at this data, what do you think, the third row, blah, blah, blah. So it's quite immediate. We don't have the use case that you want to preserve this kind of data view or selection in time for publications. Good point.
Okay, thank you.
Thank you. Oh, there is Andrea.
So sooner or later, you three will die, and then we will have data browser 3.0.
Who knows?
And I think your JSON generated UI is a good step to be future proof. I was just curious which other technologies you think you created or you put in place to be ready for data browser 3.0. Do you have in plan something like that? Because the JSON generated UI is, I think, a good step.
Yeah.
We have also some other technologies. Yeah.
Sustainability in software development.
Yeah.
My software engineering question. So.
Yeah, so thank you for your nice words. What do we have? Yeah, something that's, I think, technology agnostic is the query state stuff. So how you handle it and how you can inspect it and how you can observe it and how this stuff should work in any framework. Other things. Whew.
What will you change when Vue 4 becomes like?
Go.
Anything that is related to rendering the.
Become a farmer.
Yeah, go to find a real job.
So anything that is closely related to the UI stuff and framework stuff needs to change then. I don't hope so. I don't hope they make such a step with Vue 4. But so the principles behind on how this works should stay the same. Those were two principles. I'm not sure what else could be reused. But yeah, there is another state management for the UI, for example. So stuff like this is also reusable. And maybe the texts. But tough question, yeah.
Any other question or comment?
If not, before you go, I would ask everybody to just tell his name and say his affiliation. So afterwards, with the nice beer.
Before starting, I make some advertisement now.
Okay.
So everyone is here. If you go on the Open Data Hub website, under the events, you will find the upcoming events about Open Data Hub. The next one is the next Software Developer Thursday. Martin Rabanser will present us what he did about proof of concept of an MQTT broker to collect data about the airplanes that are passing over our heads over South Tyrol. So he will present us how he did, and so it's a first step to open up also to this technology in the Open Data Hub. And then the 20th of May, we will have a hackathon, an online hackathon. So in the next month, we'll open the registration, but you find there also more information if you want. And we opened the call for speaker of the Open Data Hub Day that will be held the same day of the hackathon, the 20th of May. So if you have some project interesting to present, just post your call for speaker, and then we will be glad to evaluate it together with the committee and come back to you and have you as speaker at the event. So feel free to post us some some call for speaker proposals, and so that was my advertisement. I'm Stefano of NOI, part of the digital team together with Patrick, and I'm helping in the coordination of the whole Open Data Hub project, and I pass the microphone to Patrick.
Thank you, Stefano. My name is Patrick Honewein. I'm working at NOI Techpark, coordinating the unit digital, and we are doing this Open Data Hub project.
I'm Matthias Wallnöfer, Computer Science teacher at the Technologische Fachoberschule Max Valier. And during my lessons, I cover also the topic of the Open Data Hub, software architectures, and I do projects with my students.
I'm Ilaria Russo, I'm 21 years old. I'm studying business informatics in Bolzano.
I'm Simon Dalvai, and I'm software architect here at the NOI Park, working with Patrick, Stefano, and Peter. And yeah, I also work sometimes on the Open Data Hub. And thank you for the presentation.
I'm Andrea Kraus, I'm studying at the University of Bolzano Computer Science, and thank you for the presentation.
My name is Christoph Anusna. I'm based in Switzerland, just across the Ile-de-France, and we are running and operating our startup hub, or an incubator as we like to call it, in Zenetz. We deal with computer science and specializing in space. So we build strange things that go up in the sky.
Gianluca Antonacci, environmental engineer, company achievement here at NOI Techpark.
I'm Tommaso. I'm a computer science student, Visa, doing my first year of the master.
I'm Tim. I'm writing my thesis on a data science topic right now with a company from here, from Bolzano, and it's about electric vehicle charging, so it's similar in the area.
Hi, Daniel Moronini. I work at the Keep in Mind company, and I'm also a master student in software engineering. Yeah, thank you for the good presentation.
Philip Giuliani. I'm also working at Keep in Mind and mostly in backend and frontend.
Janis from the Free University of Bolzano, and yeah, I'm interested in complicated software engineering problems.
Alex Wieser, also working at the Keep in Mind as a backend developer for streaming software.
Hello, hi, Matteo. I'm an assistant professor at the University of Bolzano and software engineering research group, let's say.
I'm Danilo Fink. I'm startup founder at Kibun and also software engineer.
Hi, I'm Peter Moser. I'm also part of the Tech Transfer Digital here with Patrick and Stefano and Simon and others. And mostly at the moment occupied with the Open Data Hub, various statistics, Postgres database optimizations, and software licensing.
Hi, my name is Martin Robanza. I'm a business and technology consultant. I work closely with the guys from the Open Data Hub, mainly the community, building community, and pushing forward the project. Yeah.
Hi, I'm Benjamin Cobrel. I'm one of the co-founder of Anthropic, and we are building knowledge graphs, the one that Patrick showed before, so one for the Open Data.
Hi, I am Paulinho Fonseca. I am a researcher at the University of Bolzano, working with ontologies and data modeling.
I
I'm Andrea Ganellos, Center for Sensei Solution of Iraq Research, work with databases and application for spatial datasets.
My name is Roberto Monsorno, working at Curac Research, coordinating the Center for Sensei Solutions, and I strongly believe that open data can really give a power to innovation and even business.
Last but not least, the speaker.
Yes, I'm Christian. I'm working as a freelancer, and yeah, I'm working on front-end, back-end stuff. So whatever there is to do.
Anything in between.
Yeah.
Maybe
So,
there are still some beers.
Thank you everyone for being here. Don't forget, in a month we see us here for the next time. And enjoy the remaining beer and drinks and have a chat all together. See you. Bye-bye.
Bye.
Bye.
Bye.